Find voltage across 2 ohm resistor using superposition theorem in the following circuit. Okay, this is the question actually given. Here, this is the 10 volts voltage, 2 amps and 20 volts. Total 3 sources are given. Okay, 10 volts, 2 amps and 20 volts. And we know that the superposition theorem, only one source must be in acting and other two sources, that means here total three sources are there, one source is in acting, other two sources will be replaced by, if voltage source is there it is replaced by short circuit, and if current source is there it is replaced by open circuit. So likewise 10 volts will be acting in step 1, in step 2 2 amps will be acting, in step 3 20 volts will be acting. That means 10, when it is 10 is acting, these two are replaced by open circuit and short circuit. Similarly, when 2 amps is acting, others are replaced by their internal resistances. Likewise for 20 volts also. Okay, let us come to the first circuit. That means when 10 volts are 10 volts is acting alone, when 10 is acting alone, 2 ampere current source means replaced by open circuit, and the voltage source is there, it is replaced by short circuit. Okay, let us take the circuit, redraw the circuit. Here 2 amps, 2 amps is there, I have replaced with open circuit, and this 20 volts is there, I have replaced with short circuit. Okay, this is the actual circuit we got in the step 1. Now what I am doing is, here in this one open circuit is there, if it is open circuit, this branch, total branch can be eliminated because no current will be flowing in the branch. Okay, so I am eliminating, the modified circuit will be like this: 10 volts, 10 ohms, 20 ohms, 2 ohms and this 5 ohms. Okay, this is the modified circuit. So I want, in the question they are asking, find voltage across 2 ohms, voltage across 2 ohms, that is between point A and point B. So we cannot get directly, we can get the voltage across the node, but we cannot get directly. So for that purpose, first we find the voltage across this node, then we will find the voltage drop at 2 ohms. Okay, so let us apply nodal analysis technique. So when I apply nodal analysis technique, so when I apply nodal analysis technique, how many nodes will be there? There will be two nodes. This is the junction point and this is the one more junction point, because all are connected here. Okay, now I am applying nodal analysis. So when I apply nodal analysis, this will be acting like a highest potential, so all three currents will be leaving. That means this is I1, this is I2, okay, and this is I3. Three currents will be there. I will show you. Let me clear. Okay, this is the circuit. 10 I1, I2, I3. I am applying the nodal analysis technique. Nodal analysis means you have to apply Kirchhoff's current law. This is acting as highest potential, means all currents are leaving currents because no current source is there here. So I1 plus I2 plus I3 is equal to 0. What is I1 here? Current flowing from node VA, node A to ground. That means not ground, node A to 10 volts. So VA minus 10, because current entering from positive to negative means minus minus only. So already this is a voltage, this is also a voltage. Just we are I am applying I is equal to V by R, Ohm's law. V is equal to IR, I is equal to V by R. So what is V? V is VA minus 10 and R is 10 ohms. Similarly I2, so I2 is flowing from VA to this ground. That means VA minus 0, VA minus 0. So no need of writing 0. Okay, VA minus 0 by 20 ohms. Similarly, where I3 is going from VA to ground only, no? So VA minus 0 by, how these two are connected, and these two are connected in series. So I am adding 2 plus 5. Okay, this is the equation. When I can write the VA coefficients. So if I write the VA coefficients, it will be like VA of 1 by 10 plus 1 by 20 plus 1 by 7 is equal to minus 10 by 10 is 1 minus 1. If I shift right side, it is plus 1. when you do the LCM of this, the value is 0.29 approximately into VA is equal to 1. So from this VA is equal to 1 by 0.29, which is 3.41 volts. Okay, this is plus 3.41 volts is the value we got. That means only node voltage we got, but we don't know what is the voltage across A and B. This is A and this is B. So we need to find that one. So I got that at this point VA and this 0 is there. No, I got this voltage. I got this voltage means simply I can replace this resistor. No, so I'm replacing this by 3.41 volts. Okay. Now I am very much interested only for this loop. Okay. So here how actually this is a parallel, but in this parallel 10 volts is there. You will not get 10 here because there is some voltage drop at 10 ohms. If there is no voltage means the same voltage is applied here. That means 10. Because of this resistor there is some drop. So 10 is there. It will be consumed. That means 3.41 is there. No, the remaining voltage drop will be at this 10 ohms. So we got only remaining voltage 3.41, so not 10. Okay, that 3.41 I have written here, and this VA, this 2 ohms is there, 5 ohms is there, 2 and 5 like that only. So how it is, this circuit is just like a voltage division only. No, so for this total resistors I have connected with voltage source, that is VAB is equal to, this is acting like VAB is nothing but V total. Okay, total voltage VAB is equal to, I want voltage across this particular resistor, that is VAB is equal to total voltage into particular resistor by the total resistor. These two are connected in series, that is 2 plus 5. So what is total voltage? Total voltage is 3.41. Particular is 2, because particular voltage we want to know 2 by, and this 2 plus 5 is 7. So when you multiply and divide, you will going to get 0.97 volts. See here, I am considering in this direction. Okay, so in the step 1 also I have considered in this direction, step 2 also the same direction, because when you are doing, you consider the same direction for all the circuits. Okay, so here we got as VAB is equal to 0.97 volts. This is step 1. Let us go to step 2. What is step 2? Here we will see. Let me clear all this. Okay, this is step 2. In step 2 the circuit is there. No, in the previous circuit only 2 amps I am considering. Now only one source must be in acting, that's why alone, and remaining sources voltage is there. No, that's why short circuit. Here also 20 voltage is there. No, that is short circuited. So here this is the 10 volts and here is the 20 volts. I made short circuit. So after making this, what you have to do, you have to find the nodes. Okay, how many nodes will be there? This is node 1, node 2, node 3. 3 nodes are there, means n minus 1 equations. That means 3 minus 1 is 2 nodal equations I am going to get. This is nodal equation 1 and nodal equation 2 will be at B. Okay, so apply nodal equation at a node A. So when you apply, let us consider the currents I1, I2 and I3, because no current sources at node 1. No? So all currents will be in leaving, that is I1 plus I2 plus I3 is equal to 0. Just same, VI is equal to V by R, Ohm's law we know. What is V? I1 is nothing but V means VA by 10, I2 is VA by 20, and I3 is from A to B. No, so A to B, that is VA minus VB by 2, which is equal to 0. So I am again taking the coefficients VAB and VA separately. So I am going to have this equation. Okay, let me clear all. So when I shift this, when I take this coefficients, if I do the LCM, I am going to get it is 0.65 VA minus 0.5 VB is equal to 0. So this is the node 1 equation. Similarly, node 2 equation can be applied at B. No, at node B. That is, we can see that, just see here at this node B, one current source is there. If current source is there, don't disturb the direction. The direction will be in towards the node itself. That is 2 amps is I am indicated with I4, and remaining I3 is there. No, previously I have taken I3 this direction. Now I am considering I3 in from B to A position. I3 and I5 are leaving currents and I4 is entering current. Okay, that's why sum of currents entering towards the node is sum of currents leaving the node, that is I3 plus I5 is equal to I4. So I3, how you will write from VB to VA only, no, VB minus VA by 2 plus VB by 5 is equal to 2. So if you substitute that values, what is VB minus VA? Okay, so here I am taking the coefficients of VA now. Minus 1 by 2 VA is 0.5 VA. Here coefficients of VB is 1 by 2 plus 1 by 5 here is equal to 2. I will have the equation minus 0.5 VA plus 0.7 VB is equal to 2. After solving these two equations in the calc, I am going to get the values of VA and VB. That is, VA is equal to 4.87 volts and VB is equal to 6.34 volts. But the thing is, which direction actually we need to follow? So in the step one, I followed the direction in clockwise direction. So here also I have to follow the direction from A to B only. That is, from A to B means clockwise only. So that's why I have taken VAB, not VBA. Okay, VAB is potential difference between two. So I got the voltages. No, VA I got as 4.87 and VB I got as 6.34. So VA minus VB is 4.87 minus 6.34. So you will have the value minus 1.46 volts. Okay, so that is step 2 answer. In step 3, 20 volts is acting now, the last one. Okay, the first two will be replaced by voltage source, will be replaced by short circuit, and current source is replaced by open circuit. So redraw the circuit. The circuit will be like this. Okay, the circuit will be, okay, this is the actual circuit I am going to have. That is this resistor, and this is the open circuit. This will be the applied voltage. So the modified circuit will be like this. Because it is open, no need of taking this branch, so we can eliminate that. 10 ohms, 20 ohms, 2 ohms, 5 and 20. So only two nodes are there. This is point A and B, this one and this one. So nodal analysis I can apply, and there is no current source. Because of that, all currents will be leaving currents. So VA is assumed as highest potential. So I1 plus I2 plus I3 is equal to 0. What is I1? VA by 10. I2 is VA by 20, and I3 is VA. I3 where it is going from VA to 20 voltage, no, VA minus, from plus to minus means minus 20 by 2 plus 5 is 7 is equal to 0. The coefficients of VA is 1 by 10 plus 1 by 20 plus 1 by 7, and this is the minus 20 by 7 is there. No, I am writing right side. So you will have the coefficients, this value as 0.298 VA is equal to 2.85. So this is the voltage I got, VA value, the nodal equation only I got. That means up from this resistor, I can replace it by voltage source as 9.7 volts. Okay, 9.7 volts actually I got here. Okay, so that is why I am replacing this as 9.7 volts, because I want the voltage across this branch, not the nodal equation. Okay, at A to B, that means at 2 ohms. So I got this. Again I am applying, I am applying mesh analysis, that is loop analysis. I cannot take the voltage division directly, because another voltage source is also there. No, so previously I did voltage division because only 9.7 is applied. But in this case, I'm having two voltage sources. One is 9.7, another one is 220 volts. Now thing is, which direction you need to follow? Clockwise direction. Why? Because we have considered from VA to VB only. No, that's the direction I am going to consider. So just apply KVL. So when you apply KVL, here 2 ohms is there. So current direction from here means the drops will be plus to minus. The resistor will be replaced by drops only. No, plus minus likewise. And the voltage sources are fixed voltage, that is plus minus and plus minus. Minus 2 I1. This is first resistor at 5 ohms, minus 5 I1. Current I have assumed as I1. This is current is flowing from positive to negative, that means minus 20. And here current is entering from negative to positive, that is plus 9.7 is equal to 0. So minus 7 I1, this is minus 7 I1 together, and minus 20 plus 9.7 is 10.3. So minus 7 I1 is equal to 10.3. I1 is equal to 10.3 minus 10.3 by 7, which is minus 1.47 ampere. So I got I1 value I got. But what I want, I want voltage drop. In the question they asked about voltage drop only. So V2 ohms. Okay, at V2, at the 2 ohm resistor, the drop is what? We know Ohm's law, V is equal to I into R. What is I? I is current, series circuit, no? So current is I. This is I is replaced by I1 and the resistor is 2 ohms. Okay. What is I1 value? Minus 1.47 and resistor is 2. Minus 1.47 into 2 is, the value will be minus 2.94 volts. So these are the three answers which we got. Step 1 answer, step 2 answer, and this is step 3 answer. What is superposition theorem states? All the individual responses, okay, we got the response at 2 ohms only, no, all the individual responses you need to add summation of that one, that is step 1, step 2, step 3. If you add all those values, you will having, that means minus 1.47 minus 2.94 and initially plus, initially what you got in step 1, we got as, in step 1 we got as 0.97. Finally we will have 0.97 minus. So when you summation of all that answers, you are going to get minus 3.43 volts. This is the final answer. That means this is from A to B. The voltage, okay, from A to B direction. Suppose if you want B to A, if you want B to A means B to A, if you want B to A direction of current means you will be having plus 3.43. Just polarity is reversed. Okay. Thank you. Let me close.